I put a bunch of stuff up in the content library on OneNote. You may or may not have noticed. So like the new notes for Chapter 3 that I use when I'm giving the notes are there. The new problems for Chapter 3. There's 3 worksheets that we're going to do with Chapter 3. And those are all in the in the content library on OneNote. You can just leave them there for now. You don't need them right this second, but that's where all those things are in reference, or that I might reference. They're all just in the content library. I also put the key to the Chapter 1 test up in the content library also, that I passed back last time. If you were gone last time when I passed back the chapter test, I have those. So like Grace and Elizabeth and Ashley, you guys wanted to grab your tests, they're just sitting right here. So you can come up and grab them now or later, or whatever you want to do is fine with me. Just try not to forget before you leave. Okay with that. Once I have all the tests taken from Chapter 2, I'll put the Chapter 2 key up in the in the content library also. And we'll pass those back. It just, as soon as I ever get them all taken. You know what I mean? You guys cool? All right, so should we start? Let's do it. All right. Okay, so let's start with just kind of a little bit of an info dump. So these are going to be just a list of key features for the sine function and the cosine function. So just like we did in our Algebra 3-4 class, when we talk about graphing these things, we're going to be graphing them as transformations of their parent functions. We have a domain, range, symmetry, continuity, amplitude, midline, period, and frequency. And we'll explain what some of these terms maybe we're not familiar with, and that's okay. We'll explain kind of what each of these things are in a moment after we kind of do a little info dump here, okay? So I'm going to just make 2 columns, and I'll do a column for sine and a column for cosine, and I'll color code them, so hopefully it's easy to kind of tell things apart. So the parent function for sine is just y equals sine. And the domain is all real numbers. That was one of our big accomplishments last chapters. We've now redefined sine and cosine so that you can take the sine or cosine of any angle, which means the domain for those functions are now all real numbers. The range for sine is bounded between -1 and +1. If sine is still in some way related to like this unit circle thing, the biggest value on the unit circle would be 1 or -1. So those are the biggest value you can have for sine or cosine. Symmetry, here we are odd for sine. We have that odd symmetry. So symmetric about the origin. The continuity, we are everywhere continuous. So there's no breaks in our graph. The amplitude is 1. The midline is y equals 0. The period is 2 pi. And the frequency is 1 over 2 pi. And now I'm going to do the same list for cosine. Don't worry if you're not sure what all these things mean. We're going to go and define some of these unfamiliar terms in a moment and draw a little picture to kind of illustrate what we mean by that. So the parent function for the cosines is just y equals cosine x. The domain is still all real numbers. The range is still -1 to +1. A cosine function has even symmetry. It's symmetric about the y-axis. It is also everywhere continuous. Its amplitude is 1. Its midline is y equals 0. Its period is 2 pi. And its frequency is 1 over 2 pi. So make that a little bigger there. I assume everybody's got that first column written with what all these things were. Okay. Come on. There we go. So the graph for sine looks like this. And again, you don't really need to copy these things down. I'm just kind of embedding them into the notes so that if you go look at the notes, you'll have a picture to go along with it. So this is the graph of y equals sine x, the parent function. And we'll look at the graph of y equals cosine x next. Again, rather than me trying to draw them and doing a lousy job because my art skills are subpar, I'll just generate them electronically and then drop them in to our document so we have a nice complete document. But this is my graph of cosine. If you compare the two, they look awful darn similar, right? You guys agree? In fact, they look so similar. How might you describe them? One in terms of the other? Looks like the same graph. It's just been shifted left or right a little bit, right? You guys agree with that when looking at the pictures? Yeah. Okay. So let's zoom out now a little bit. And let's define some of this stuff that we just have, some of these key features that we've just written down. So in chapter 1, we talked about the notion of a parent function, domain, range, symmetry, continuity. Those are all familiar terms. We have yet to define what we mean by amplitude, midline, period, and frequency. So let's discuss what those things are, okay? So some definitions. So the amplitude of a wave, the graph of sine or cosine we call, are kind of look like waves, right? So the amplitude is half of the total height of the wave. This is half the distance between the maximum and minimum y values of the wave. So those of you that have been in a chemistry class, you guys might have done something with wavelength and frequency. There's a, what's the one, whose equation is that relates wavelength to frequency? Anybody remember? Is that a Maxwell equation? What's that? You don't remember? It's okay, I don't remember either. That's what I was asking, if anybody remembered. But like, wavelength is equal to period times frequency or something. Was that something that you talked about in your chemistry class? Does that ring a bell, maybe? Okay. Well, whatever. If it doesn't, if it's not ringing any bells, it's not worth rehashing, right? Like if it's, you don't remember that anyways, it's not going to be a helpful metaphor for us, so let's just move on. The midline of a wave is the average value of the wave that is the line that cuts the wave in half and lies halfway between, that's just my abbreviation for between, the maximum and minimum y values. This means that the amplitude is the distance from midline to maximum or minimum y value. Probably should have an article there, to the. And we'll draw a little picture here when we're done and kind of illustrate what we mean by these things in our picture, okay? So far, so good? Coolsville Daddy-O's? All right. The period of the wave is the length of one full cycle of the wave. Since sine and cosine repeat we say that these waves are periodic. Okay, and then the last one is frequency. Okay, so the frequency of a wave is the number of cycles a wave completes in 1 unit time. So the frequency and period are going to be necessarily reciprocals of one another. That is not what I wanted. Woohoo. Whoa, laggy McLaggersons. So let's take an example here, like this wave that we have drawn right now, and talk about what visually what we mean by things like amplitude and midline and period. Okay? So again, if you want to draw this, cool. If you don't, no big deal, because it's here in the notes that you can always come back and look at. But it's just me trying to give you a visual definition of what we mean by these terms, because we write them down and you're not probably sure exactly what that means if you're to look at a piece of paper and go, how would I figure out the amplitude of this? Okay. So I'm going to choose to draw in the midline first. Yes. Of course. Because I think it's the easiest one to see visually. So the midline is just the line that kind of divides the graph into two equal halves. So you have as much of the graph above the midline as you do below the midline. So in this case, our midline is like right about here. Right? I guess I didn't draw that very straight. I'm going to do a better job. Come on, Mr. Kulik. Nope, still got a heavy finger or something. Still got a heavy finger. You know what I mean? It's hard to do this, especially on the tablet, right? That's maybe better. So this is like our midline. So if I look, I have kind of as much of the graph above the midline as I do below. Does that make sense? Visually what I'm saying? Okay. The amplitude is half the distance from a low point to a high point. So you're taking that distance and dividing it into 2. That's our amplitude, which again, as we said, was also the same thing as the distance from the midline to a maximum or minimum. Either of these would be considered an amplitude. Is everybody okay with that idea? Okay. The period is like one non-repeating segment of the graph. I think the easiest way to see that is like from midline back to midline, basically. So if we start at the midline here, we have a crest off. So that part hasn't repeated yet. The graph is still, those are two distinct pieces. But then we would start a trough again. Or I'm sorry, a crest again, right? The up humps are the crests and the valleys are the troughs, I think is the terminology when we talk about waves. Ocean people, does that sound right? Anybody an ocean person in here? Surf's up, dudes. Okay. So we'd say that this distance here is what we mean by the period. Is that horizontal distance. Everybody so far so good? Okay. So let's talk about graphing then. So we mentioned in the last chapter, if we have some parent function f of x, any transformation of the parent function can be written as g of x equals a times f of 1 over b x minus h plus k. So if our parent function is, say, sine of x, our transformation is going to be y equals a times sine of 1 over b x minus h plus k. And for cosine, that transformation would be y equals a times cosine 1 over b x minus h plus k. Does that all look familiar? So all we did was apply that general transformation for any parent function to the specific sine function and the specific cosine function. And you should also then recall Hi, Joe.
There you go.
Thanks, my dude.
Go.
Elizabeth Housey, this is for you. I'm going to put it with the test here, so when you come up and pick that up, you can grab that. It's not for now. It's after class. So I just figured, like, who cares, right? We can get it then. Okay. Just don't forget. Okay. All right. And we recognize this, right? Again, we use this in chapter 1 to do our transformations. So the question becomes, what are these key points that I need to use? The answer is, we're going to find those on the unit circle. So if I look at my unit circle for a moment, let me kind of explain to you what I'm doing. So we have our unit circle, right? If I wanted to graph sine of x, and I wanted to use radians, the radian value would be my x-coordinate. And remember, the y-coordinate on the unit circle represents the value of sine at that angle measure. So the first point I would graph would be the point 0, 0. And then my next point would be the point pi over 6, comma 1/2. And then I'd have the point pi over 4, root 2 over 2, then pi over 3, root 3 over 2, etc., 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 right? Now, it turns out that we can get a pretty good picture by cutting out some of, not using all of these points. So we're actually going to drop all of these guys in the middle, and we're just going to use these, what we'll call quadrantal angles. So let's write those down on the other page. I'm going to erase all of this stuff because I just now realized that I did that on the unit circle on the content library, and I don't want all those marks to be there when you guys go to, if you were to go download a unit circle of your own, it'd be pretty annoying to be like, why is all this highlighted stuff on here? I just want to look at the unit circle, for God's sakes. So for sine, actually we'll do it over here. We have 0, 0. We have pi over 2 comma 1. Pi 0. 3 pi over 2 negative 1. And then 2 pi 0. To find the key points for cosine, we do the same thing. But instead of at the unit circle looking at the y-coordinate, because that was sine, we're going to look at the x-coordinate. That's cosine. So 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then 2 pi 1. Everybody, so far so good. Would I ever ask you to generate these 5 key points again? No. We're just going to use these every time we want to do a graph of either sine or cosine. Those are the points that we're going to be transforming respectively. So you'll use these every time you graph a sine or a cosine function to do the transformation. So let's do a little example here. Yeah, that's fine. So let's say we want to graph y equals negative 4 sine of 2x plus 1. The first thing I'm going to do is I'm going to identify the values for a, b, h, and k. To do that, I'm looking at this general form for a transformation. So what's my value for a have to be? Negative 4. Good. And what's our value for b? 1/2. Good. And h is 0. And k would be 1. So now I can write my transformation map. So bx plus h, y plus k. And because we're graphing a sine function, I'm going to be using the key points for sine. Bless you. You're welcome. So I'm just going to copy those down from above. And then to get my transform point, I'm going to plug my x in for the x spot and my y in for the y spot. Is everybody okay with how I generated those points? Okay. So if I were to go to graph this, 1, 2, 3, 4, 5 up on the y-axis, 1, 2, 3 down on the y-axis. And now if I look at my x-coordinates, they're all look strange because they're in terms of pi's, right? But I don't care about that. The part that I care about is that I see 0, 1/4, 1/2, 3/4, and 1. Did you guys see that when we look at that, ignoring the pi's? So all these x-coordinates are equally spaced, right? So all I'm going to do is make like 4 equally spaced spots and call the last one pi. Is everybody okay with that idea? And now I'll plot. So 0, 1. And then the next spot is pi over 4 then, so that's -3. And the spot after that is pi over 2, and that's back to 1. And then 3 pi over 2, that's up to 5. And then back to pi, which is back down to 1. So if I connect these then, that is one period of my graph, right? What if I wanted more? What if I asked you to graph 2 periods? Well, 1, 2, 3, 4 evenly spaced tick marks, and I'm just going to repeat the pattern. So we're back at 1, so the next one we should be at is down to -3. Back up to 1, up to 5, and then back down to 1 again. I don't even need to generate any more key points because I know the graph is the same thing over and over and over again, right? And if I wanted another period, I would just extend another one, either forwards or backwards, and I can do that as long as I like, depending on what the directions of my problem ask for. What do you guys think about that? That's not too bad, right? So what if we also asked you, in addition to finding the graph, what if I asked you to describe the transformation in words in the proper order? Remember, the order we do is B, A, H, and then K. So the B value was +1/2. So we have no reflection from the B. But the magnitude of B is less than 1. So we have a horizontal shrink. The A value is negative. So there we have a reflection across the x-axis. And the magnitude of A is bigger than 1, so we'd have a vertical stretch. the h equals 0, so we have no translation left or right. And the k is positive, so we're going to go up that many units. Again, this is exactly like we did in chapter 1, right? Nothing changed. The way we did the graphing was exactly the same. The way we described the transformation is exactly the same. Nothing has changed. Everybody okay with this? What about these other key features? How are those going to change with a transformation? Well, let's go back to our list of those key features. We'll add another column or two for these transformations and fill in some of those values. Sound good? So I'm going to go back to here. And I'll do a column for sine and one for cosine. So, is a transformation going to affect the domain if the previous domain was all real numbers? No, right? No matter how we stretch or shift or reflect, the domain was all real numbers before, it's just going to be all real numbers again, right? So the domain remains unchanged. How about the range? No, correct? If I stretch vertically or shrink vertically, the range is going to change, right? Will that change be multiplicative or additive? Multiplicative, very good. And then if we shift the graph up or down, is that going to change the range? Yes, right, the y-coordinates would be different, correct? So the range should change. Will that change be additive or multiplicative? Additive. So my range then is going to be negative a k comma a plus k. Oh, actually, let's write it a different way to keep, because a could be positive or negative, right? I got to be a little bit careful here. So let's do k minus the absolute value of a, and then k plus the absolute value of a. That'll make sure that nothing gets goofy with the order of my interval there. And that'll be the same for both sine or cosine. And then the other thing that we're going to worry about then is the amplitude, the midline, the period, and the frequency, and seeing how those change. So the amplitude is the distance from midline to like a maximum or a minimum, right? If I pick up and move that up or down, is that going to change that distance? No, right? The distance would remain the same. If I move things left or right, is that going to change the distance? If I stretch things vertically or horizontally, will that change the distance? Vertical, yes, right? If we stretch it vertically or shrink it vertically, that distance is going to change. So, the amplitude is just going to be the size of A. since the amplitude before was 1, if I multiply by a, that'll get me my new amplitude. And because it's a distance, it's always a positive number, so we'll just take the absolute value of a. Okay? So the midline is the spot that divides the graph in half, like from horizontal perspective. If I shift the graph left or right, is that going to change the midline? No. If I stretch the graph vertically or horizontally, is that going to change the midline? No. Right? The midline's going to be stuck there, dividing the middle of the graph in half. If I pull equally on each end, the middle of the graph is still going to be the same spot, right? Can you guys see that? What happens if I shift the graph up or down, though? Is that going to change the location of the midline? Yes. So the midline is now going to be y equals k. And here the sign does matter. So notice there's no absolute value around the k. And then the last thing we need to talk about is the period. Since I know the frequency is just the reciprocal of the period, if I can do the period, I can do the frequency. So the period is the length of the graph for like one segment of it, right? If I shift the graph left or right, is that going to change the length of that segment? No. If I move it up or down, will it change the length? If I stretch it vertically, will it change the length? If I stretch it horizontally or shrink it horizontally, will it change that length? Yes. So it's the b value here that's of importance to us. So it's going to be the same as before times the b value. And again, because the period is a length, we'll put an absolute value around the b to ignore whether it was negative or positive. Okay. And then since the frequency is just the reciprocal of the period, we can just copy those right in. So let me zoom in and get a nice... Oh my gosh.
This one's for a Chris Skull.
A Chris Skull?
Yeah.
This is Chris Gull, not Crystal.
Oh, no, I said, this is the mask, I'm sorry.
Oh, that's okay. Chris, this is for you.
No.
No, it's after class. I'll set it up here with my pile of things to be picked up. You can grab it whenever. I just want you to go to the office to pick something up, it looks like. Is everybody okay with that? So let's go back to our previous problem and write down the amplitude, the midline, the period, and the frequency for that previous problem that we just graphed. Sound good? We'll use the formulas that we developed here, but we'll apply it to the specific problem we just graphed a moment ago. Okay. So what's the amplitude going to be for this problem? Well, remember the amplitude was the absolute value of A. So our A was -4, so our amplitude is just 4. What's the midline going to be? Well, the midline was y equals k. In our problem, the k is 1. What's the period going to be? Well, remember the period was 2 pi times b. In our case, the b is 1/2. Oops. Was the absolute value. Not that it mattered in this particular problem, but I should probably be technical about that. So the period is a pi. And then the frequency would just be then 1 over pi. Yes? Of course. We should do the domain and range here. Well, the domain we noted didn't change, still the same as it was for the parent function. But remember, the range was kind of weird, right? It was k minus the absolute value of a, and then k plus the absolute value of a. So in our case, that goes from -3 to +5. Notice that you could have also gotten that just by looking at the key points that we transformed, by looking at the minimum value there and the maximum value. Let's do one more, huh? We'll do one more graphing example, do the whole shebang. Maybe I'll write it down, let you guys try it for, 5 minutes or so, and then we'll go through it together. What do you say? I think that's probably a good idea. Okay. So let me write one down. And I'll pick a tricky one. Well, I'll just make a tricky one. Oops. Let's do it that way. That'll be even trickier. Okay. What do we need? So we're gonna, I want you to write down A, B, H, and K, the transformation map, the transformed points, the graph, describe that transformation in words, and then domain and range, amplitude, midline, period, and frequency. So I'll give you guys, I don't know, 5 or 10 minutes here to do this. We'll go through it afterwards. We'll be done for the day. We'll figure out what you can do for homework. Or I'll figure that out while you guys are working on that problem. Cool? Righteous, my dude. Okay, quick little check-in here, because if we made this mistake, it's going to be problems later. What did we get for A? -2. What did we get for B? 1/4. What do we get for H? It's not 3 or 3 pi or -3 or -3 pi. So remember, it has to be written like this, where the b is factored out. So if I factor a 1/4 out, what does 3 pi turn into? 12 pi. Yes. Oh, thank you. Yes. I got going too fast. Glad you pointed that out. Yes. How many of you want to quit now? That's okay. That's a mistake that after we've pointed out to you, you probably won't make again because it's such a crummy one to make, but it's easy to forget about, right? This was something I think happened on the test 1 quite a bit, where we forgot, I think almost everybody forgot to factor the b before they found their h on one of the problems on test 1. A couple of people came in and asked me about it after I passed the test back, but that's got to be careful about that. All right, so let's rip through the rest of this, huh? So our transformation map then becomes 4x. Oops, that's a minus 12 pi, excuse me. Minus 12 pi. And then -2y minus 2. So we have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and then 2 pi 0. So this becomes -12 pi, and then -2. And then I have 2 pi minus 12 pi, which would be -10 pi, -4. Then I have 4 pi minus 12 pi, which is -8 pi, and then -2. I have 6 pi minus 12 pi, which is -6 pi, and then I have 0. And then I have 8 pi minus 12 pi, which is -4 pi, and then negative again. So let's go by 2 pi's here, right? So 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi. So here's -12 pi, oops. -12 pi, 2. -10 pi, -4. -8 pi, -2. -6 pi, 0. And -4 pi, -2. So that's what my graph, at least one period of my graph, is going to look like. Keep in mind it keeps on going. Maybe I'll do like to indicate that. So in words, so b is greater than 0, so we have no reflection across the y-axis. And the magnitude of b is greater than 1, so we have a horizontal stretch. and the A is less than 0, so we have a reflection across the x-axis. And the magnitude of A is greater than 1, so we have a vertical stretch. The H is less than 0, so we're going left 12 units. And the K is less than 0, so we're going down 2 units. Is always negative infinity to positive infinity. Our range is going to be K minus the absolute value of 2, and then K plus the absolute value of 2. Absolute value of A, which comes out 0. Oops. Which is, again, exactly what we see here. And then the last thing we have is the amplitude, which is the absolute value of A, so that's 2. The midline, which is yk, so that's going to be y equals negative 2. The period, which is 2 pi times b, which is going to be 8 pi. And then the frequency, which is 1 over the period, so 1 over 8 pi. What do you guys think? Hopefully that doesn't, well, it seems like a lot of work. Not that bad once you got the hang of it. So from the homework set, you guys can do 1 through 6 and 9 through 12. And worksheet 1. Oops, didn't want to minimize that. Sophia.
No, I'm sorry.
Oh, you're just stretching.
Yeah.
Good stretching. You fooled me good. That's all the pile there. You're welcome. Yeah, no problem. Chris, who do you guys play tonight in the foosball?
Harper Woods.
Harper Woods.
Yeah.
You're probably there. Oh.
Is this homework due this Sunday or next Sunday?
Well, what do you got? What's already due this Sunday?
Yeah, it's the reverse touch.
Wait, why is there a thing to do if we already took the test?
Because you should have done it before the test. I'm just not checking it until after the test because I'm checking only on Sundays. Yeah, I do all the checking on Sunday just because it's